think we've hit the mark, so I'll get started. Today's presentation again is on the ITM 4DW, and let's get this going. So, as we start with every one of these brown bag luncheon WebExes, a statement of our mission. Our mission at Anderson-Negele is to provide complete sensor solutions and services for hygienic process engineers in dairy, food, and pharmaceutical. And you know, as usually each week we talk about some device that we've got for internal process in a processing facility, and it's a little different this week because the ITM 4DW kind of works on the fringe of that. So, if anybody's visited our website in the last week and you went into the turbidity section, you might have noticed that there are 3 selections now for products. Of course, we have our ITM 3, which has been around for a long time, and then the ITM 4, and we have a new addition. It's the ITM 4DW, and it is looks somewhat similar to an ITM 4, but there are some differences, and we're going to go through those now. So, for those who are not familiar with the ITM 4 and the ITM 4DW principle of operation, this is a flow-through turbidity sensor. That means that we're going to have to cut the pipeline, put in ferrules, and this will clamp into the pipeline, and all of the liquid in that pipe is going to flow through it. Around. So this view that I have pictured here is actually looking through the flow tube. So what that device employs is 2 light emitters and then 2 light detectors. Because of course turbidity is the measurement of how particles present in a liquid or in a media affect the transmission of light. So we need light, and then we need to pass it through the liquid to determine how the particles have affected. Well, in the case of the ITM 4 and 4DW, it's somewhat unique because we have those 2 lamps. So our lamp illuminates into the stream, and we have light that is transmitted across to the other side of the stream. That's one of our measurements. Our second measurement is the light that is reflected at 90 degrees to our second detector. So we measure the intensity of both of those lights. What's unique about the ITM 4 and 4DW, though, is we have a second emitter, and that second emitter, when we turn off one and turn on 2, it changes the function of the 2 detectors. So the light, the sensor, or should say the detector that was measuring transmitted light is now measuring scattered or 90-degree reflected, and the other one is obviously doing the other function. And what this gives us is the ability to realize what's happening to the tube and to the optics. That means that over time, if this is in a pipeline that's starting to get cloudy or get scaled to it, we can compensate for the fouling of the optics and give us a much longer operational life than competitive products. So what does the ITM 4 and the ITM 4DW measure? Well, they measure units called NTUs, or net thermometric turbidity units. And that's the 90-degree light, scattered light measurement that we showed earlier. This is a standard that was developed by Hawk in the 1950s, utilizing the Formazine standard. Formazine is a powder that's dissolved into water at varying concentrations to establish a baseline of turbidity values. And so each one of these devices is calibrated using Formazine as its basis. The range of operation in ITM 4DW, this is a minimum range of 0 to 5 NTUs, which is common for purity applications. Meaning if I had pure water and I wanted to determine when it's corrupted, I would typically run in a 0 to 5 NTU range. It's also 5 NTU is the magical point that the FDA looks for corruption of water when they're doing water reuse in a plant. Now the 0 to 5,000 NTU range, that's the overall range capability of the device. To put that into frame of reference, 5,000 NTU is somewhere around the value of skim milk. And so we do not apply ITM4s, and we certainly would not apply ITM4DWs into dairy applications. So it's really relegated to purity applications, confirming that water is clear, confirming that a liquid is at a low turbidity state. Specifications, we have 11 preset ranges that can be assigned to the 4 to 20 milliamp output. Any 4 of those 11 ranges can be selected and remotely selected through the use of DC inputs to this device. That means that we could have this device configured for 4 different ranges by giving it outside inputs of 24 volts, turning on any one of those ranges for operation. Of course, it's got a 4 to 20, an active 4 to 20 milliamp output. That means this device would be a 4-wire device. It can be wired as 3-wire, meaning that we would tie together the 2 commons for the output and the input. It does have a 24-volt DC switched output, which can be used for the set point that can be internally programmed. That means you could program this device to trigger at a specific NTU value and turn on that output. That would be common to use for like diversion. If something got out of spec that you were measuring and you wanted to divert it, you would take that output. Or for an alarm to let you know, more manual, but to give you an alarm that something's amiss and needs attention. Within the all-in-one design, of course, an ITM4DW is identical to a 4, and that means it's an all-in-one device. The electronics are on the flow tube. We have a 2-line LCD backlit display, giving us a reading of turbidity and typically also the status of the switched output, as pictured in the photo below. 2 M12 connectors, you need 1 if you simply want to power up the device and take the 4 to 20 milliamp out. If you're going to use any of the advanced features such as the switching or the remote range selection, you would need a second cable connecting with that M12 connector. Again, as mentioned earlier, alternating beam method, compensation for the following of lenses, and an 860 nanometer wavelength means that this device is color independent. So it doesn't distinguish between white and black. It is solely looking for particle concentration in the liquid and the way those particles affect the movement of light through the stream or passage of light. And then lastly, an ITM4DW utilizes an LED light source that's for longer life, much longer life than traditional incandescent bulbs. And that again drives to the fact that this is a turbidity sensor that is color independent. So why does the ITM4DW exist, you might ask? We've had the ITM4, it's worked great, it solves applications in dairy plants around the world. Why did we come forth with an ITM4DW? And it's interesting in that the ITM4DW comes from a large opportunity to measure turbidity on the gas scrubber of a ship. So the opportunity came driven through a separator manufacturer who was providing a separator for a gas scrubber that needed to ensure that the water that was clean enough before it was discharged back into the ocean. And so the demands of that application brought about the need to become very price sensitive for the ITM4 design and also to change the size of the body to accommodate this system. So we came forth with this very specific application that drove some changes in the design that we then looked at and said, well, this has got applicability beyond the ship. And so that's why I'm here talking to you now. So what did the design give us? Well, it gave us 2 things. An ITM4 has a single measuring block that has a 65 millimeter bore within it. That means the hole that goes through the actual part where the optics are. And for the ITM4DW, we had to create a second block, which was smaller, so it's a 40 millimeter block. In addition to that, we had to reduce the cost of plastic, and the ITM-4 currently uses PEEK as its material. PEEK's a fairly expensive plastic, and the shift went to PPSU, which is polyphenol sulfone. Still commonly used in potable water applications and some life science applications, but it does not meet 3A requirements. And in addition, the reduced bore 40 millimeter, because we had to shrink down the bore, we could no longer meet 3A radii requirements. So keep in mind when you're looking at an application and you're thinking about using an ITM-4DW, it has to be a non-3A application. The reward for that, though, is that you have a device that costs less. So it has a propensity to find itself in applications where the ITM-4 might not have been able to quite convince someone that they wanted to make the move on it. So we were able to reduce the costs overall through the material change and through the size reductions. So boring in a little bit more on the size aspect, because even these pictures are a little difficult, even though they're exactly to scale. What you notice, or what you need to notice, is that the block in the upper photo is of a standard 65 millimeter block. And as it's pictured here, it's shown with 2-inch tri-clamps. But if you've purchased an 1.5-inch ITM-4, you realize that the reducers have to become longer, and there's a much more dramatic change that occurs when you go into a small 1.5-inch pipeline. That sets up a little bit of a challenge when it comes to cleaning, because we want to maintain velocities, and also in purging things such as gases or air from it, because we've got kind of a wide spot in the line that slows the liquid, makes it a little bit more difficult. So now the ITM-4DW, for the smaller sized sensors, utilizes the 40 millimeter block, and so that is pictured here with the 1-inch connection on it. And you can see that when we would be putting a 1.5-inch connection on it, it would be almost a size on flow through. That means that we eliminate the transitions, make it easier to go and flush the device out, makes for quicker purging, and also cuts down on the amount of stainless that we have to use to manufacture it. So what hasn't changed? Same accuracy as an ITM-4, same temperature rating, same pressure rating, exact same electronics, programming structure is the same, and the same M12 wiring. The key to that statement is you need to make sure that you order it with M12 wiring. So the ITM-4DW does have an option where you do not get M12s. Instead, you would get a standard PG connection for cord grips. Lower costs to meet industrial price points of non-3A applications. So this takes us typically a little bit away from our core. We don't walk into a dairy plant and start looking for process pipes to stick ITM-4DWs on. We're more so looking for applications that don't warrant sanitary products, such as any time we see water use. One that comes to mind is any discharge water application. This is in any instance, and in particular in a lot of drilling or construction applications, where any water that's returned to the environment needs to ensure that it meets EPA requirements. The ITM-4DW can solve those needs, meaning that you can put this on a discharge line for water into a field and ensure that you're meeting the government requirements for the quality of that water. In addition, any water applications, and that means any water processing facilities, any filtration systems, any drinking water applications, and ITM-4DW is going to be great for it. And then well applications, and this is on any plant that uses a well, whether it's a water facility or a dairy. If you need to monitor your well because of sediment and the like that can increase depending on changes in the environment, the ITM-4DW would be great, because again, you've got that long Service life with the constant compensation for fouling means that you don't have to remove it as often. It is a continuous device. It's always been one of the advantages of the ITM4 design is that we're not sampling. Instead, we're continuously monitoring. So what we need to do is we need to keep in mind that the ITM4DW is there for water applications. Some of the matrix changes and the price difference. Probably the whole crux here was, well, you've taken these materials and made the changes. How does it affect the end result, which is list price on this device? And so on the left, I've got an ITM4DW price page, and you can see that what's important is we do have 3 fitting types listed, and we want to make darn sure we're ordering the first set, which is the ASME tri-clamps. So TC1, 1.5, TC2, these are the choices we want to make. We don't want to go down into the TC40s, 50s, or 25s. Beyond that choice, as I mentioned earlier, we have the electrical connection, because if you take an X, you're going to get a PG16 cord grip on the device. You'll want to get the M12 to get that full environmental protection. But here's the comparison. Take an ITM4 2-inch, you've got a list price of $8,100. Take an ITM4DW with 2-inch and M12, list price $6,698, nets out of a $1,402 price difference, or about a 17% reduction. That can get us into water applications where in the past someone might have gone, well, that 8100 is a bit of a step for us. Well, suddenly now you're down into the mid-6,000s and it can be navigable. One point at this time is we do not or are not currently stocking the ITM4DWs. That means that all of the units that are ordered get ordered directly with our facility in Germany, which means that we have about a 3-week lead time on the devices. So, as we look at this and how do we move forward on this, now that we've got 2 devices, they almost look exactly the same. There is, cautionary notes on misapplying DWs into standard ITM4 applications. Understand the ITM4DW is there to go into the non-food applications. That means water and other substances or other products that don't require 3A approved product. The 3A approval of the ITM4 is still important in most dairy applications, even on the services side, because a lot of the like cow water lines are still kept to 3A standards, still kept CIP-able. So it's important that we still purchase the right product for those applications. So dairy, cow water, still an ITM4 application more than likely. Beverage separation, food processing, anytime we're in the line process, or I should say monitoring product. That's the end of the presentation. I do want to remind you all not to forget you should receive an email in about 30 minutes containing the PER for a special discount on both the ITM4 and the ITM4DW. And now I'm open for questions. Type them in, please, and we'll answer them as they come. Any questions? Got a question on where in brewery applications would we see use of this? There's a couple applications. First off, very common brewing application is on the discharge of a separator. So it's to enhance separator control. We take away time-based measurement of, or I should say time-based discharge of sludge on a beer separator, and instead go to a turbidity-controlled application. There's also final quality applications where we're trying to ensure that we have the right clarity. So you've got separation typically a little earlier on, and then at the tail end. Any other questions? Question is, where is the product manufactured? As I mentioned earlier, all orders will be coming from Germany, so it is manufactured by Negele in Germany. If I don't hear from anyone in another minute, we'll close this up. Last chances. All right, I guess we'll call it. Thank you all for attending. Have a happy holiday. Stay tuned for the next one.